Let's use what we learned about e and the idea of limits to take a look at another limit. And we're going to use our calculator for this. So I'd like to compute the limit as x approaches infinity of e to the negative 2x plus 7. Quite frankly, at this point in time, the easiest way to do this problem is to make a table. So we're looking for the limit as x approaches infinity. And so when we do that, what we're going to do is we're going to plug in larger and larger and larger values in for the x. So what I'm going to do is I'm going to make a table. And so in my y1, I'm going to put the function. So I have e raised to the negative 2x plus 7. And notice the negative 2x I put in parentheses. And again, the way the calculator will do this, it'll do e raised to that power. And then it'll add 7. So this is exactly this expression. And then I went and I made a table. So when I went and made a table, I looked at 0, 1, 2, 3, 4, 5. And notice by the time I get to 5, the calculator is rounding. It only shows up to 4 decimal places. And so notice it's rounding to 7. But you'll notice I actually illustrated here that when when x is 5, it's really 7.00004539993. But it's getting really, 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 really close to 7. And so what we'll actually notice is the limit as x approaches infinity of e to the negative 2x plus 7 is in fact 7. This is a good way of doing limits, to make a table and look to see where it goes to. Now, we're fortunate here because e is an exponential function, so it tends to approach whatever it's doing rather quickly. Sometimes when we do problems, we aren't at 5, we're at 500 or 5,000 to find this out. But e, because of its exponential nature, does do its approaching piece rather quickly.